My research is in neuroscience. I'm very interested in how the brain works, and we study different aspects of brain functioning. Specifically, we are interested in perception, how do we see, and in memory, how we can form new memories and how we can recall experiences from the past. So the Jennifer Aniston neuron was a neuron I found in one patient some time ago that fired to many different pictures of Jennifer Aniston. So these are recordings that are done for clinical reasons, to try to cure patients from epilepsy. And this allows us the opportunity to record single cells in human subjects. So what I found is that in this patient, I show many different pictures of Jennifer Aniston and the neuron fire, and I show many other pictures of other people and the neuron did not. So basically what this means is that there are neurons in the human brain that represent concepts, as opposite to particular visual features of one picture or the other. So basically, building up from the finding of these Jennifer Aniston neurons, we realized there are neurons that represent concepts. And these neurons are actually in areas that we know that are very much involved in memory. For this, we did an experiment that was done by Matthias Sison, who is a lecturer here in the center and also at the engineering department. And what Matthias did, he was showing different people in different places, like for example, Jennifer Aniston by the Eiffel Tower and so on. So then we saw that the neuron that was originally firing to a person, say to Julia Roberts, the moment the patient remembered a new memory, start firing also to the associated place, like the White House. And this happened even after one trial. And that's critical because this shows for the very first time how neurons can encode memories even after one presentation, which is what happens in the human brain, because we only need to see something once to be able to remember it. The impact of these findings is to understand a very basic mechanism of memory formation. And I think this has a huge impact for basic neuroscience because the long-term possibility that might be helpful for pathologies like Alzheimer's disease. And this is because Alzheimer's involves exactly the area that we study, which is the hippocampus. So we want to understand Alzheimer's disease and potential treatments. You first have to understand how the normal brain works. And when we understand the mechanism of the normal brain, we can wonder what happens in the pathological cases so that leads to these devastating conditions. I think the brain is one of the most interesting things that is yet to be understood, and I consider myself quite privileged to be able to work on that.